of whether something is a relation, is it a function, or is it one-to-one function, okay? So relation is just a set of ordered pairs. Okay? So, for example, 3, 5, 4, 7, 8, 12, 3, 25 would be a relation. Set of ordered pairs. Again, instead of ordered pairs, the first number is the what? The x. And the second number is the y. Because I want to know the answer. See, he laughed at my joke there. He's going to pass class.
Yeah.
Okay? Yeah, so the first number is the x, the second number is the y value, right? All right. So that is a relation, set of ordered pairs. The step up from that is when you get into when something is a function or not. And so for something to be a function, you get that for every x, you can only have one y. So for every x, there will only be one y value, right? So my first set of points I gave you, we said it was a relation. Does it also describe a function? No. Why not?
Because there's two values.
Right. The problem is you got a 3, 5, but we also have a 3, 25. So this one x value goes to two different y values. Therefore, it's not a function. Right? So if I want in terms of an example of something being a function, then we could go in terms of something like this. That would be a function. For every x, there is only one y. Okay? Yeah. How about this way? Is that a function? Yeah. Doesn't matter that they're all the same y number, because that's not important. Okay? What is important is that every x corresponds to a unique y value. Okay? So you have, given a set of ordered pairs, you got to be able to tell if it is a function or not. Okay? The other way you should be able to tell if something is a function or not is given a graph of a function. So, for example, so on the board I got 4 graphs. So we'll go back to when you were younger, before the days of trig class and physics of sound classes and all that good stuff. Way back when you were younger, back in the days of the Grouch, Kermit the Frog, and the good old days of Sesame Street. Right? And you got to that segment of the show that says one of these is not like the others. So in terms of my graph, one of these is not like the others. Is it graph number 1? Is it graph number 2? Is it graph number 3? Or is it graph number 4? One of these is actually a graph of a function. How many think it's graph number 1? How many go for graph number 2? How many say graph number 3? And how many go for graph number 4? The correct answer is graph number 3. And the way you can tell by looking at a graph is, does it pass what is called the vertical line test? So you take my piece of paper and I bring it through. So like here it cuts the graph, it really cuts the graph because it really wipes it out. Well, now that you got, you would cut that in several places. It's not a function. A circle is not a function. Okay? This one, it only cuts that red line every spot in only one place. And the last one also would not be a function. Okay? And once you get past that vertex point, it cuts it in 2 places everywhere. Okay? So you can tell a graph by what is called the vertical line test. Okay. Easy enough to tell. Okay. Graph function should only cut it in one spot. Okay. If it doesn't, it's not. Right? So we had a relation. We had a function. Right? For every x, there's only one y. Well, the next step up from that is you get to, is the function 1, maybe?
It's always that section of the board.
Okay. Doesn't like that piece. So is the function, there's something wrong there. Yeah, they come down here, it's fine. So is the function 1 to 1, right? Right? So for a function to be 1 to 1, we got, first off, for a function, you got that for every x, only 1 y, okay? But in order to be 1 to 1, you also have to have for every y, only 1 x. Right? Right? So both conditions have to be true in order for it to be 1 to 1. So if you go back to this, we said this is a function. Is it also 1 to 1? Got a 50-50 shot. How many say yes? Okay. How many say no? So this half of the room says yes. This half of the room says no. Okay, basically. And the answer here is that it is not 1 to 1. The way you can tell on a graph is it would actually have to pass the vertical line test, but then it also has to pass the horizontal line test. It's got to pass both tests to be 1 to 1. Right? Any question on that?
4 wouldn't be 1 to 1, would it? Passing through both of the axes.
It's not even a function.
Not even function, okay.
It's already out of the running right away.
Only one y. So are there? So sometimes you'll see an x and 2 y's, which is obviously not a function, but for one x there's one y, and for
So-
y there's one x.
So Bailey, do you want an example of a graph that would pass my criteria of 1 to 1? So the easy example. Straight line. Going up at some slope is 1 to 1. Right? So a linear equation, unless it is a horizontal line or just a vertical line, is 1 to 1. Okay? So that passes both the vertical and horizontal line test. Right?
Is that because anything that's curved has more points?
Okay?
And so it's not 1 to 1?
Basically. Yeah. So if you think about a sine wave, think about an angle, right? You got, it's a function, okay, but it's not in terms of that being 1 to 1. Because you got that if you go the other test, you will hit more than one spot. Because like the sine of 30 is 0.5. You also have that the sine of 150 is also. Which we'll get to in a few weeks. After all, sine is a trig function, right? All right. So this would be a graph of 1 to 1. Again, the easy example is a linear equation. It's a 1 to 1. Okay. Right. So we got functions. Right. Okay, you're aiming.
I have a question. For the graph number 4, why
Huh?
for the graph number 4,
Yeah.
why isn't it 1 to 1?
Well, first off, it's not a function because it does not pass my horizontal line test. So if I do a line here, it cuts it in 2 points, right? So this isn't even a function. Okay? So, right? So it's not even a function, okay? So 1 to 1 is basically a special type of function. Okay? It's next step up for a function. Okay?
So it's only passing through each of the axes one time. The function is
Okay, for a function, again, for every x you only get one y.
correct.
Right? So given an equation, which we'll get to in a moment, you should be able to tell is it a function or not. And then also you can tell which one's what. Okay? Okay? Yes?
So for one x you can only have one y, but for one y you can have multiple x.
Right. So like this is a function, right? I could also, if you go back to a basic graph, go back to a straight line graph. That is a function. Every x only has one unique y value. The y values are all the same, given that truly is a horizontal line. Okay? That doesn't matter for a function. For a function is that every x can only give you one unique y value. Okay? Anything else on that? No? Okay. All right. So given a graph, you have to be able to tell is it a function or not. Also given the graph, you can tell if it's 1 to 1 or not. Okay? Simple little horizontal vertical line test tells you that information. But what about if I gave you an equation and asked you, is it a function or not? Okay? So let's say we got something, let's start with something easy. Y equals 2x plus 3. Right? Straightforward, right? That's an equation of a what?
Straight line.
Straight line, right? That's a straight line equation. Okay, remember from back in algebra class, mx plus b? Right? Linear equation, right? And it would be a function, right? For every x number I plug in, I will get a unique y value, right? I plug in 5, I get 13. That's the only number I get when I plug in 5, right? If I plug in 0, I get 3. You plug in negative 20, you get negative 37, okay? So for every x we plug in, I get only one y value. Okay? It's a function. Okay? What about now? Is it a function? No. Got a 50-50 shot, right? I know, it's a yes or no question, right? Is it a function? Yes or no?
I mean, because like depending on what you put in for x, it's gonna be a different square root.
So, for example, what is the square root of 25?
5. Plus and minus 5.
Plus or minus 5? Actually, there are two answers. Okay? So yeah, if I plug in 25, I actually will get out two different y values, right? Okay? Now, however, square roots, they do sort of cheat, unfortunately. Okay? If I look at the actual graph of a square root function, the entire thing, your entire thing is, you get this piece going off like that, which is all your positive square roots. But the other piece you would get is you also get the mirror piece down there, which is actually all the negative square roots, okay? Which is sort of like the one graph I had up earlier in terms of is it a function or not. Okay? Now, this is not a function, right? But they like to cheat with square root. They do like most people do. If you go down the street and you ask some poor fool out in the street, you ask them, what is the square root of 16? What are they going to tell you? 4, right?
Wrong.
Well, that should say. But hopefully they knew that the square root of 16 is 4, and that's probably the only answer they're going to give you. They will only tell you the positive answer, right? Not that there actually are 2, but there's only, and so what they do for square root, when they talk about the square root function, they mainly wipe out the bottom part of that curve, and like most people, you're only talking about the positive answers, right? So now you got the square root function, which is only the positive square roots of a number, right? Yes?
So we should look at it that way?
Yeah, and the book looks at it that way.
Okay.
They cheat. But, you know. Okay? So, yeah. If you just disregard the bottom half of the graph, okay? The other thing you will need for the toy is for this class is a toy. You do need a calculator.
TA84, TA85 standard.
Yeah. Or the appropriate app on the phone. You know?
Cheaper.
You know, whichever. But you do need some kind of calculator for this class, whatever it is, or yours, okay? So you do want to bring it. That way you can get practice how to use it, and you talk about the buttons and what they do on there, okay? That way you know what it does, okay? So it will come in handy. Again, you can find there's plenty of apps for smartphones that are calculators. So whether you want a scientific or graphing calculator, okay, on the phone. All right. So I wrote here y equals 2x plus 3, y equals the square root of x. Okay. So again, if I have something like this, y equals x squared plus 3x plus 2, which is a function, and I tell you x is 5, everybody should be able to tell me what that is, right? What is it? What?
That's the meaning of what tails at 42, so I just wrote that.
So you put it in, you end up at 42, right? Barely what that says is everywhere you see the x, you want to plug in the number, right? Right? All right. How about if x is negative 8? Huh? What number?
42.
42. Okay. Right? So again, everywhere this says, everywhere you see the x, plug in negative 8, okay? So this is going to be negative 8 squared, 3 times negative 8, plus 2. Negative 8 squared is what? 64. So this is going to be 64 minus 24 plus 2. Okay? So when you take a negative number and you square it, you're going to end up with a positive number. Okay? Now the thing about the toy or the app, when you are taking a negative number, you are raising it to a power, you want to make sure you put it in parentheses in order to get the right answer, because there is a difference. So, for example, this, that. So the top one, the answer is what? 4. The bottom one, the answer is 4. The one in the middle, negative 4. Okay? There's the difference. The one in the middle says, I want to know what is the negative of 2 squared. It also means negative 1 times 2 squared. Okay? So it does make a difference how you plug in the toy, whether or not you get the right answer or not. Okay? Alright. Right. So we had in terms of y equals, you then get in terms of what is called function notation. Okay. F of x equals 2x plus 3. Okay. We basically, f of x is basically the same thing as y. Okay. But it does tell you that this is indeed a function, which means it passes that criteria, that for every x there is only one y. Okay? So we had before, if I gave you this equation and I wrote it out this way, y equals 2x plus 30, and I tell you x is 5, we get that y will be 13. Okay? So now the way you see that in terms of this notation is will be, I want to know what is the f of 5. And it means exactly the same as what we did over here. It says where you see the x, take it out and plug in the 5. So 2 times 5 plus 30. And again you get 13. So function notation, and plugging in a number, a value, whatever it is, okay? And getting the answer. Again, you get f of x equals that's a function, right? If I say, find the f of 10, that would mean everywhere you see the x, you're going to plug in the 10. So 10 squared minus 3 times 10. And we end up at 7, right? Now, what if I said, what is the f of that? Well, really almost the same as what we did when we plugged in the 10, except for now, everywhere we see the x, we're going to plug in x plus 1. So now we're going to get x plus 1 squared minus that. And again, you go back to your good old days of algebra stuff, right? X plus 1 squared. Okay? What does that give you? So it will be x squared plus 2x plus 1. After all, what does that mean? This means x plus 1 times x plus 1. That's what that means, right? Okay? And so, everybody remember the thing called FOIL method? At some one point in time, long ago in your memory banks? Kind of, right?
Front, outside, inside.
Yeah, first, outer, inner, last, or depending on whatever they use for it, right? So you had FOIL method, okay? F stood for first, which in this case will be the x times the x, which is x squared, okay? O stands for outer or outside, depending what they use, which in this case is x times the 1. So this will be x. I've got 1 times x is x. I stood for inner, or inside, depending on what you use, which in this case will be the 1 times x, which will be another x. And then L stood for last, which will be, in this case, the 1 and the 1, which will be 1. Okay. First, outer, inner class was that whole method, right? And then the next thing you had to do was combine and simplify what you can. Again, for polynomials, you can only combine those things that are similar. Apples with apples, bananas with bananas, kumquats with kumquats, and so on. Okay? So if I simplify this, we end up at x squared plus 2x plus 1. So this is x squared plus 2x plus 1. But then we have this, the minus 3 times this term, which will be a minus 3x minus 3. Right? And so lastly, when it's all said and done, we have only the 1x squared term. We got 2x minus 3x, which will be a minus x. And then we have 1 minus 3, which will be that. Okay? Any questions on that? You will next week when you do your homework. Okay. Now function. So given a function, we can talk about what is the domain, what is the range. So if you took the reasoning of MAT1300 class, you had some questions on there, on the My Foundation Lab, that dealt with domain and range, right? They asked you, okay? So domain refers to which, the x or the y? The x, right? So the domain refers to the x variable, okay? In the more general case, it also means that it corresponds to the independent variable. The range refers to what? The what? Right? And in the general case, this would mean that this corresponds to the dependent variable. So again, you were like in the one I had up earlier, y equals 2x plus 3. The x was the independent variable. As soon as I plug in a number for x, we know what y has to be, right? So the value of y was dependent upon the x number. Okay? Right? So in terms of the first example, domain and range, again, you go back to like what you had in the math 1, 2, 3, you had stuff like this. Okay. So given that set, it does describe a function. What is the domain? Right. The domain for this one are the numbers 3, 5, 7, and 10. That's the domain. What's the range? 7, 8, 12, 20. The y numbers, right? So that's the domain and range. given a list of points, you should be able to tell what the domain and range are. Domain will just be all the x numbers. The range will just be all the y numbers. Okay. How about given something like this? What's the domain? What can I plug in there for x?
1. Plug in whatever number.
I can plug in any number I want, right?
Plug in 1.
Any negative number, I can plug in 0, I can plug in any positive number. So my domain here is going to be from negative infinity to positive infinity, okay? And again, you had in terms of whether it's the parentheses or brackets. After all, you can never actually be infinity, right? You never actually get there.
Probably all infinity.
So that's why it's parentheses. Bracket means you go up to and actually touch that number, whatever it is, okay? Now, what's the range? I plug in all those numbers. What comes out?
Anything?
What?
Is that anything?
Anything, right? I'll get negative numbers. I will get positive numbers. I can even get 0, right? So yeah. So my domain and range in this case for this one are the same. Negative infinity to positive infinity and beyond. Okay. Well, what about if we talk in terms of square roots, but we talk in terms of the square root function, okay? And I have this. I'll go back, this is the same as y. Okay. What's my domain? So what numbers can we take square roots of in the real number system?
Positive.
And
0.
0, right? You can take the square root of 0, that's not a problem. You can, so 0 and up is fine, right? You cannot take square roots of negative numbers in the real number system. That's only totally different, okay? So given this one, what will be my domain in order to make this true?
0.
Not 0 to infinity. Negative 2 to infinity. After all, the bottom number we can do is, I know that this number in here has to be greater than or equal to 0, right? So I take this part, and I solve that for x. Opposite of adding? Subtracting. X has to be greater than or equal to negative 2. Okay? Now, if you go back in terms of that lovely interval notation, which everybody was using either parentheses or brackets, if I do this in terms of that notation, you're going to get the square bracket and then the parentheses. Okay? Right? Now, given that I'm talking about the square root function, what is the range? 0 to infinity, right? Because we said 0 square root function, we only talk about the positive side of my graph, right? So my range is going to be 0. And again, it will be like that. It will be 0. But again, you can never actually get to infinity, right? Okay. So you have, given an equation, what's the domain and range? The other thing with the domain and range is given something like open point, let's say this is negative 10. Right? Yes, all you should be able to do is given a graph. What is the domain and what is the range? So given that graph, what is my domain?
Negative 10 to 10.
Negative 10 to 10, but this is an open circle. So in terms of interval notation, you get that. So if it has an open circle, it means it goes up to but does not include that point. Okay? What is my range? Negative 7 to 7. Okay? And again, same setup as this one. Like that. Okay? Any question on all that? Ranges? What?
Confused on the brackets.
Okay? So brackets, you notice here that on this one I have a closed circle. That means it actually includes the point 10, 7. Okay? This one down here means it does not actually include the point negative 10 and negative 7. So it includes, for example, the point negative 9.999999999, comma, negative 6.9999999, right? Okay. But it does not include that point, okay? So the parentheses means I go up to, but I don't include negative 10. I go up to, but I don't include negative 7. This means I stop at 10, and I include 10. This means I stop at 7, and I include these 7, okay? Is what that means. Okay. All right. And with that, let's take a 15-minute break. So that's why I'm going to be back here at quarter after. Break it up and stretch. And I said, find the slope. Everybody looks at it and wonder, what is slope and how do I find it, right?
The graph function on the calculator.
The graph function on the calculator. Well, slope, if you remember, slope was the rise over run, which is also the change in y over the change in x.
Which is y2 minus y1 over x2 minus x1.
Correct. And then you get down to y2 minus y1 over x2 minus x1, right? Change in y over the change in x, right?
I have a question that might be a little esoteric. Why does it matter if it's y2 minus y1 instead of y1 minus y2?
Because it just doesn't matter.
Okay, that's what I thought, but.
Okay. It doesn't. Okay. So, for example, we go back up to my points. If I call this point x1, y1, I call this point x2, y2. I take those numbers, I plug them into my equation. We get 21 minus 7 over, what was it, 8 minus 3? 21 minus 7 is going to give me 14, and this will be 5. Right? And generally, in terms of slope, you would leave it in terms of an improper fraction. So, if I plug the numbers in the opposite way, I get exactly the same answer. Or it really doesn't. Okay? Either way you do it. Okay? So slope is a measurement of the rate of change. That's what slope is. Telling you how fast is your equation either increasing, decreasing, whatever. Okay? So slope is also rate of change. Rate of change, right? So, for example, and 12, 11, something like that. Okay? So a chart. Top number is years, second number is price. Okay? I want to know what is the rate of change between 2010 and 2009. Oh, sorry. Hey. Well, let's change that. There, now we got 2009. Takes care of that problem. All right. So rate of change between those 2 years. So we got the 2010 price was 312, and the 9 price was 299. So 312 minus 299. 2010 minus 2009. So the top number will be what? 513, the bottom number is just going to be 1, right? So it went up 13 cents in a year. Is what that tells you, okay? 13 cents in 1 year is my rate of increase. Okay? How about if I wanted it in terms of 2009 and 2012? What's the rate of change?
It'd be 0.68 over 3, and then you'd have to do
Right.
the division.
It'd be 0.68 over 3, right?
Well, like 22 the remainder of 2.
22 2/3 cents per year, right?
Yeah.
Okay. Again, rate of change is the same thing basically as finding a slope. Right? So in terms of like the in-class work, you'll see one that looks like that. Give you a chart, give you a couple of years, whatever. Tell me the rate of change.
Well, we're mainly just adding and subtracting, we're not multiplying this numbers for rate of change. It's pretty simple.
No, rate of change is the same thing as your basic slope equation. That's all it is. Change in the y over the change in x. So in this case, the change in price over the change in time. Same thing. My first example, 13 cents per year. My second example, 22, so 0.22666 cents per year.
We don't want to put, oh, it went up 5% this year, or but the rate of change was 13.6% annually.
Yeah, you talk about, if you have, your stock market. How much did it go up, how much did it go down, right? You can talk about percentages. you watch the stock report every day, they tell you that. They tell about how many points up or down, but then it also tells you in terms of percentage change, up or down. Right? That. You think in terms of your savings account at your bank, which maybe pays a whole APR of 0.7, 0.9%. APR. So savings account don't pay much. In terms of putting money away. Right?
Sometimes a lot of money in there is actually.
Yeah.
That's interesting.
Right? Any question on rate change? That equation. So, for example, you drive around, you go by some time and temperature clocks. It will tell you the temperature both in Fahrenheit and in Celsius, right? So this equation lets you convert between the Celsius temperature and the corresponding Fahrenheit temperature. Okay? So 9/5 times the Celsius temperature plus 32 will give you the corresponding. So for example, you have that on our scale, the freezing point of water is how much? 32. The boiling point of water is 212 on our scale. Okay? On the Celsius scale, freezing point is 0. Boiling point is 100. Okay? So basically when that scale was set up, they used those two numbers as the reference points. Okay? Now, however, it ends up when he first initially set up the scale, he reversed the two numbers. He called the boiling point 0. He called the freezing point 100. And then somebody later looked at it and said, this makes no sense, that as something gets warmer, the temperature is decreasing. And so they flipped those two numbers around. So it actually makes sense.
It is the amount of coldness.
Okay? But yeah, he actually originally labeled those 2 points the opposite way. Okay. All right? So this equation, this function, lets you correspond from one to the other. So, for example, given this equation, if the Celsius temperature is negative 40 degrees, what will be the corresponding Fahrenheit temperature? So, negative 40 Celsius corresponds to what on a Fahrenheit thermometer?
104 degrees.
What was that?
104 degrees.
No.
I got negative 40.
Yeah.
It would be negative 40,
Okay.
which is why I like
Oh, I
using that
threw it
number.
up with the negative.
It's the only time where you will get the same temperature on both thermometers. It's the only time it ever occurs. Yep. Because again, Belly, what I would do is I plug in, right? TF equals 9/5 times negative 40 plus 32, right? 9/5 times negative 40 actually ends up giving you a minus 72. And you end up back at negative 40. So, only time it happens. You get the same reading on both thermometers. So if you think about being somewhere like in International Falls, Minnesota, in the middle of winter.
But then you can throw like the thermal. Never mind, I'm sorry, I was just thinking like thermometers.
Okay, that's when you get those kinds of temperatures. Okay. Right. All right. So in terms of an equation, right? My equation, my function. And then I want the inverse of that. So what happens in terms of a function and its inverse? Well, in terms of a function and its inverse, is that the domain of one becomes the range of the other. Which basically in terms of x and y, is what that means is you flip-flop the x and y's, is what that means. So if I write the inverse of this, we're going to have x equals 4y plus 3. Hello?
Can you stop by my office on break?
Uh-huh.
Thank you.
Right. So we get that. Right? Now the other thing with this, however, is I actually want to take that equation that I have there and I want to solve that equation for y. So we're going to take a few moments and see if you can solve that equation for y. So that equation I got in the blue, I want to solve it for y. Okay, go back to your basic algebra skills, right? How do you solve an algebraic equation, right?
That already solved this.
No, I want to solve it for y. I want to isolate this. So that equation in blue, I want to make it in the form of y equals.
Isn't that point slope form technically? That's y equals, because then it'd be y equals mx plus b.
Yeah. No,
I have x minus 3 over 4.
that'd be better. So I take this equation, we want to solve it for y, okay? So again, you go back in terms of algebra, how do you solve things for a variable, right?
Isolate.
So the way you move things in algebra is you always do the opposite operation. So the opposite of adding is to subtract. The opposite of subtracting is to add. The opposite of multiplying is to divide. And the opposite of dividing is to multiply. Right? And whatever you do on one side, you have to do on the other side. Right? So, if I want to isolate the y, first thing I want to do is I want to take this 3 to the other side. So, we're going to subtract 3. We're going to subtract 3. so we get x minus 3 is going to equal 4y. Well, 4y means 4 times y. Right? And so the opposite of multiplying is to divide. Right? And so we're going to divide this by 4. We're going to divide that by 4. Right? And so we get y equals x minus 3 over 4. Okay? So you could leave it like that. If you want, you could separate it. It would say exactly the same thing, if I do. If I separate this out, it would be that. Either way, it means exactly the same. You don't have to do that. Question on that? Well, this one. So if I'm talking about my square root function, first off, what is my domain?
X.
Well, given that equation, what's my domain? What's the domain?
Negative x to positive x.
Huh?
0 to infinity.
What?
0 to infinity.
0 to infinity. Again, domain refers to the x, right? And again, square roots, I can only take numbers, square root of numbers that are 0 or greater, right? So my domain is 0. And again, this would be a square bracket because it can be 0. And again, you can never actually be infinity, right? What's the range?
Zero.
0 to infinity.
0 to infinity.
Bottom to top. Okay. And it's exactly the same setup, right? Now, what if I do the inverse of this? So the inverse, we flip-flop the x and y's. Okay. So if I do my inverse, we're going to get x equals, okay. Now again, if I want to isolate the y, what do I do this time?
Square both sides.
Right. So the way you get rid of a square root is to square it. And whatever you do on one side, you have to do on the other side. So I'm going to square this, and I'm going to square that. And so we get y is going to equal square. Okay. opposite of square root is squaring. The opposite of squaring is to take the square root. The way you move things in algebra is always by doing the opposite operation. Well, if I talk about it, if I did it in, well, that one, x could be any number, actually. You know, if I didn't talk about square root being square root function, as you do. Because actually, x could be any number in that case.
So it's negative.
Yeah, y could be any number. Right? In terms of that case, right? If not, okay. Again, as I mentioned earlier, the book for the class is under the job sharing tab. Sorry, yeah. Nothing wrong there. Web tab, sorry. Textbook for the course. And I have to. And actually, this book is actually put together by a couple of people from over actually University of Washington. As far as where's the source of it? Okay. It is a real book. You just don't have to pay for it. Okay. All right. Alright, so the book. So the first chapter, again, the stuff we went through is from chapter 1. So function notation, we talked about. Okay, in terms of x and all that good stuff. Right. So we went through that. And when you go through here, you get to the end, they give you plenty of examples in here. Right? And then you get to the end where it says the exercises, and so that's where you're going to, the homework questions start, okay? So really the page reference I gave you is the first page where your exercises, the problems start. Right? And again, like it says in there, you're going to do whatever multiples of 7 and stop at the appropriate number.
place in the back of the book, to like reference or like check your answers?
I think, yeah, they have some answers in the back if you go away at the end.
That means
Usually-
we're obviously gonna have to like show our work and stuff. But
Yeah, and depending, like, usually like the odd answers are included. Generally in books, you'll find that the odd answers will be in the back, even ones won't. So like for the homework, yeah, some of the answers will be there, some won't. Okay? Like, alright, so we got to this stuff, just I wanted to find another example here, alright? So you got here, again, so like I said before, like, and you'll see this in one of my in-class problems, is they give you a table. Down here, they give you the price, or like what I did earlier in class, right? For finding the rate of change, okay? So you have that kind of stuff, right? Now, in regards to this rate of change, which is what I'm going to check here, is you also get, in terms of this stuff, so let's say I have this graph. Check. Well, let's say that this is the point, let's go -8, -5. This is the point -3, 2. This is the point 4, 2. And then this is the point, let's say 10, -4, okay? I have a graph. And now in regards to this graph, I can talk about, well, where is my function increasing? Where is it decreasing? And where is it remaining constant? Okay? And you go over that, you can think in terms of slope. Where does it have a positive slope? Where does it have a negative slope? And where does it have no slope? Okay? So, from -8 to -3, what is it doing?
Increasing.
Increasing, right? So here, it would be increasing, okay? Given that my line actually is straight, what is it doing from -3 to +4? Nothing, it's constant, right? So here it's constant. And then from 4 to 10, it's
Decreasing.
decreasing, right? Okay. So we can talk about a function, whether it's increasing, decreasing, remaining constant, okay? Now when you talk about this in terms of the interval, where is it increasing, where is it decreasing, where is it remaining constant, okay? So it's increasing from -8 to -3, okay? So the interval will be given in terms of the x numbers. It's constant from -3 to 4. And then it is decreasing from 4 to 10. Okay? So if in any of the questions you got, they ask you on what interval is it increasing, decreasing, remaining constant again. You look in terms of a graph, you can tell. Okay? And when they talk about that interval, they're talking in relation to the x values. Okay? Where is it increasing, where is it decreasing? So, right? So there's that. So yeah. So they give you graphs. So like those ones, they give you a graph and they say based on the graph, and I think you have number 21 here. multiple of 7. And they say, you know, estimate the interval. So basically you gotta pick, you know, roughly where is that bottom point of that curve. So you got that it's somewhere in between -1, -2, whatever you say it is, you know. So from here to here it would be doing what? Decreasing, right? From here to here, it would be increasing. And then you got down there is decreasing, right? And no point here is it ever constant, right? Given that it has those curves, right? And the other part was inverse functions, which we talked about. Again, domain of one becomes the range of the other. Okay? All right. So you got in terms of, let's see if I can get bigger here. So you got in terms of this table, okay? Everybody able to see this table? Can you make it bigger? Okay, bigger? All right. So you got, here you got the time in minutes, and then you got the f of t, which is how far you travel, right? So they want to know, first off, what is the f of 60? So in 60 minutes, how far do you go? 50, right? So you go 50, right? What about f inverse of 60? What would that be? And so that would be 70, okay? So this one asks is how far do you travel in 60 minutes? Okay? So this says, they want to know this one, how far do you travel in 60 minutes? That's what that one asks, okay? Which would be 50 miles, okay? The bottom one says, okay, this one says, how long does it take to go 60 miles? Right? That's what that one's talking about. So now you're using the chart and reading in the other direction. Okay? Any question on that? Yes?
So how are you supposed to tell if it's different? Is it just because there's, I can't see it fully, but is there something by the 60 on the second one? That
Yeah,
makes
you
know?
got F, and then this is F minus 1.
Oh, okay.
F minus 1 means the inverse, right? In terms of notation. Okay? So you got f of x, and then the inverse would be f minus 1 of x. Again, it's notation for that.
So when you see like a letter like that with a negative number.
That means the
The
inverse.
inverse.
You even see it on your calculator. You have a calculator.
It's a -1 though usually, right?
Right, it's minus 1. So if you have a calculator, and you got somewhere on your calculator, you'll probably see where it has x to the minus 1 somewhere, or something similar to that, depending on who made your calculator. Which is inverse, or also in terms of numbers, you think in terms of reciprocals. So, for example, if you plug in 5 and then you hit your x to the minus 1 key, you should get 0.2. 1/5. That's what that would be. The inverse key or the reciprocal key, what that is. Okay. All right.
That means for the measures for x is equal to 2.
Okay.
It's just an x and then
All right.
or x to the.
Yeah, no, depending on which toy you got.
I got two.
2 or 3 different toys, right?
They're all free. I figured I would try them out and see which one.
Right, yeah, because sometimes it's easier on one app than another, depending on how they set it up. Right? So again, in terms of that notation, just because of the way the book is doing it, if I say, again, my example was y equals 7x plus 3, and then I want to do the inverse of that, okay? Right? So again, y equals, remember we said, this is also the same thing as saying f of x, right? We said that they're the same thing, okay? If I do my inverse, this now becomes x equals 7y plus 3, okay? I want to isolate the y, so we're going to subtract 3. So we get x minus 3 equals that. We're then going to divide by 7. Divide this by 7. Divide that by 7. And so we get x minus 3 over 7 equals y. Okay? Or in terms of the book and the book notation, we could also say that f inverse will be x minus 3 over 7, okay? In terms of the notation. Any question on that?
So when you do the inverse, the number of the inverse plus 3, that's the
What? Okay. Yeah.
When you do the inverse, you don't have to change. The only thing you change is the.
The only thing you flip flop are the letters. The numbers stay whatever they were. It's just the x and y get put. And you just rearrange and solve for. Right? Any other question on that stuff? No? Okay, so by the way, let's take a 10-minute break. Everybody get up and stretch.